Good day and welcome to One-on-One Maths Private Tutors. Today we are looking at O-Level IGCSE Pure Chemistry on this topic, giant covalent structures. Now, covalent structures, where nonmetals combine to share electrons, can be classified as either simple molecular or giant molecular. We have talked about simple molecular structures that are formed from only a few atoms. Example, O2, H2, CO2, carbon dioxide, ammonia, and also methanol here. These are simple molecular structures. Simple molecular structures have strong covalent bonds between the atoms. So these covalent bonds are strong. These are what we call interatomic bonds. Bonds between atoms in the molecule are strong, but they have weak bonds between the molecules. If we have molecules of methanol here, the bonds between molecules are weak. That's why they have low boiling point, because it's easy to break these bonds by just adding heat. So these bonds between molecules are called intermolecular bonds. So that is the characteristics of simple covalent structures. Now, giant covalent structures contain many hundreds of thousands of atoms joined by strong covalent bonds. Examples of substances with this type of structure are diamond, graphite, and silicon dioxide, as well as plastics such as polythene. Now, for our syllabus purposes, we are going to look at graphite, diamond, and the properties of silicon dioxide and their structures. So we are going to look at why graphite is used as a lubricant or an electrode to conduct electricity. We'll see why it is able to conduct electricity from its structure, and why diamond is used to make cutting tools. So diamond is used in tips of tools where cutting is required because of its strength. And we'll see from the structure how that strength is derived. So let's go on and look at diamond. Diamond is a form of carbon, as well as graphite is a form of carbon. But these have different structures. Though they contain carbon atoms within them, they have different structures. The structure of diamond is called tetrahedron, where we have each carbon atom there being surrounded by 4 carbon atoms, each carbon atom contributing 1 electron to the covalent bond, forming a 3-dimensional structure called a tetrahedron. So this diagram shows a single tetrahedral unit. So all these will be carbon atom, a carbon atom here, a carbon atom there, a carbon atom here, a carbon atom there, and there, forming a 3-dimensional shape, which we call a tetrahedral arrangement. So this is the tetrahedral shape. Each of these spheres will be a carbon atom. So these tetrahedrons are joined. Every carbon atom's outer shell electron is bonded to a neighboring carbon atom. Now, this makes the structure strong. That's why diamond is strong and is used for cutting tools, precision cutting tools. Only a diamond can cut another diamond. And diamond is the strongest non-natural material on Earth. That's why they say diamonds are forever, because of the structure here. Another form of carbon is graphite. Graphite is now made in layers. These layers are made of hexagonal or 6-sided rings. And these layers, the carbon atoms are bonded only to 3 other carbon atoms. So we have a carbon being bonded to 3 other carbons. Now, for every carbon, this leaves an electron out there, which can be free to move. This is the reason why graphite can conduct electricity. Carbon graphite can conduct electricity. That is why graphite is used as electrodes. Also, because these layers are made up of positive charges, since the electrons are free to move, these are positive charges. The remaining carbon ions will then have a net positive charge. So if there is a positive charge here and a positive charge there, positive, 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 there is a repulsion. And these layers can slide past one another, enabling it to function as a lubricant. Also, because these layers can slide past one another, it's easy to separate the layers. That's why graphite is also used in pencil lead. The pencils that we use to write, the dark part, that black part we use to write with, is made up of graphite. So these layers can be separated. As we are writing, we are separating the layers. So those are the uses of graphite. Silicon dioxide has a similar structure to diamond. It also has that tetrahedral structure, with the center being the silicon atom surrounded by oxygen atoms. Silicon dioxide is a very common covalent structure which is present in quartz found in sand. So we have described giant covalent structures of graphite, diamond, and silicon dioxide, and we have related the structure and bonding of graphite and diamond to their uses. Lubricant, electrode, diamond cutting tool because of its strong structure. And we have looked at the similarity in properties between diamond and silicon dioxide in their tetrahedral structure. That is the end of this topic. Thank you.